Hey everyone, welcome back to this tutorial series, and in this second part we are going to explore how you can use VoxelVision to convert any 3D model into Minecraft blocks. So without further ado, let's jump right back into Blender. So we are here in Blender 5.0, and before I start talking about how you can use any 3D model, I quickly remind you that we have this little icon down here in the left bottom corner. So in case I'm pressing any key on the keyboard that you don't know, which is a shortcut, you can basically follow along pretty easily. Where can you get 3D models? There are multiple options you can use. So either you use an online marketplace like CG Trader, Sketchfab. You can also use add-ons like Blender Kit, which is free or has a free version at least. Or you can model your own characters, models, etc. in Blender. As 3D models that you can download from the internet are more complex or more likely to be broken or like not properly made in the sense of geometry and topology and textures, I'm gonna explain how you can use it on this example. And therefore I use a model from Sketchfab, which is free. And this is the stacked scala model right over here. Which is from Abby Crawford, in case you want to use it yourself. I'm gonna import this into the scene, and you can do this by drag and dropping it into Workspace, just like this. And you don't really need to do anything at this stage, just import GLTF, for example. At this exact moment, you can already see that something is off. Before we are cleaning this up, I'm gonna remove the default cube, the camera, and the light. And then you can see that we have those skulls somewhere floating around in the scene. So let's put them into the center at first. Something around here. Something around here. And yeah, this should be quite good. And now let's have a look at the outliner first. You need to understand that there are multiple types of models or like mesh types that you can work with in Blender, and not every type is suitable for conversion into Minecraft blocks. So in this case, you can see we have a lot of separate models which are also part of this little relationship tree. And you can see we have a lot of objects in here which are basically childs of this parent, and this is a child of this parent model. And if you look closely at those icons, you can see this little triangle and this little axis symbol. And this triangle object is basically always a mesh type. And a mesh type is the best type that you can convert into Minecraft blocks. And then you have also this axis type, which is an empty object. So it doesn't hold any vertex data. It just acts like a parent object that you can use to move all objects, as you can see. So the first thing that I recommend doing is select everything and then make sure one of those is active, so highlight it in a bright orange color, and then you can go and press Alt P, and yeah, I would recommend clear parent and keep transformations so it actually stays where it is at the moment. So now you can see nothing happened in the viewport, but all these objects are now separate from their previous parent objects, and you can basically delete them because you don't need them. Yeah, the next step is to maybe join all of them together. You can do this with Ctrl J, and then you can still see the object origin is somewhere in the 3D space, and you can fix this with Set Origin, right click, and choose Origin to 3D Cursor, and now it is at the bottom of the world. And this is pretty convenient because now you can do scaling from the bottom, you can move it, you can rotate it from the bottom, and everything just works, and you don't have like a lot of headaches later down the road with stretch geometry and so on and so on. So I recommend clearing all parents that you have and joining everything together. And you can find this a lot of times if you download objects from the internet, because people don't really care a lot of times about geometry and topology. So I would recommend cleaning this up first. So the next step is to view our textures. You can do this by pressing Z on your keyboard and go into Material View. And if the textures is set up already, you can view your object in here basically. If for some reason the texture does not appear or is not applied yet, you can go into the shader editor. And the shader editor is basically what makes everything work that has to do with materials, with textures. So we have our texture in here. which we actually have 4 textures because we had multiple separate objects and then we joined them and we have 4 different textures. And this is pretty important, as you will see later on. Those nodes you can basically ignore, they're not important for now. And if you have got the setup right, you can basically then jump in and click on turn selected into blocks. One thing to notice before you do that is basically if you go into items, you can see all those properties. So we have the location, which is now centered. We have our rotation in quaternions, so you can also change it to Euler. And you can see it has minus 90 degrees. So I would actually go ahead and apply it. So you can press Ctrl A and apply rotation. So now it is basically set to 0, 0, 0. And then the scale should also be 1, 1, 1 for each axis. So it is uniform. The last section here is the dimension. So this is the actual scale that you can compare with the real world. So 1 meter by 1 meter by 2 meters, which is not a lot if you compare it to a Minecraft block, where 1 Minecraft block is already 1 meter. So in this case, this would just be like a 2 block tall model. So I would recommend scaling it up with S. So you can scale and scale and scale. You can keep track of how big your object is. So let's scale this to maybe 75 meters on the z-axis. So the z-axis is the vertical axis, in this case the height. And now you can see our scale is at 31, which is not good. You need to apply the scale again. So it is always at 1. If you don't do this, VoxelVision will then basically complain about it. So I'll keep it for now, so you can actually see what happens if you don't apply any of those transforms. So now let's go into the VoxelVision add-on panel and click on turn selected into blocks. So this is really weird, right? And this happens because you haven't applied the scale. And once we do this, you can do this by this button, which is conveniently placed, and it is an arrow. So you can click on apply object transforms. And now it looks way, way better, because now you applied the scale. It is 1, 1, 1, but the dimensions are still 35 blocks, 38 blocks, 77 blocks. So, which looks pretty nice already, but I would actually scale this up even more, something around this, apply, so you can actually see those details a bit better. All right, so this is perfect. And now you can actually take a closer look on our panel of VoxelVision. So the first button is obviously turn selected into blocks. We already clicked it, so you cannot click it again. That's why it's grayed out. One thing to note is that this is a geometry node modifier. And a modifier is basically something that is procedurally and non-destructive. So if you go into the panel over here, the properties, and go to the modifiers, you can see the VoxelVision geometry node modifier down here. If you want to see your original textures again, you can then click on hide blocks, which will not remove it, but just disable this modifier. So this is pretty convenient if you don't want to turn it into blocks and remove blocks all the time, and just hide and preview basically your conversion. If you want to remove it, you can obviously click on remove blocks. Then you can find this performance section down here. You can see how long it takes to calculate the block conversion. Because it is like real time and non-destructive, it will recalculate it on every frame if you have an animation or if you work with it. So keep this in mind. If this goes very, very high, I would recommend baking your setup. So if I click on bake, it will then tell you, oh, it's only 1.2 milliseconds, which is pretty low. So if I click on play, you can see we have a stable frame rate of 24 frames per second. Perfect. But keep in mind though that you cannot edit anything in this state because, you baked all those properties into the cache. So if you want to work with it or edit anything, you can clear the cache over here. And basically then you have access to all the settings again. The next section is obviously some operators that you can use, apply all transforms, join selected objects. If you don't know the shortcuts, Ctrl J that I used previously, you can use this button. And if you have anything that's like not a mesh and not an empty, for example, a curve or some sort of volume, you can convert it into mesh with this button over here. The next panel is the export model panel, in which you can choose in which file format you want to export your model. So schematic, XM blueprint, or MC structure. And then you can basically export it and you're good to go. The next section is the MC version control panel. So in this, you can basically turn on if you want to use modded blocks, if you want to use blocks from all versions except of 1.16. So now you can see, oh, for example, Blackstone is removed because it is in the 1.16 update. Something like this, which is pretty convenient. Then you have the modifier stack section, which basically just represents all the modifiers that this object has on this right side, basically. So if I hide this from here, you can see it also hides in here. And if you work with a lot of modifiers, which we will talk about in the next tutorial, actually, the asset library, you can then see and overview all of those modifiers in this panel, apply mask, and so on and so on. But this is not content of this tutorial because it is more advanced stuff, and we just concentrate on how you can convert blocks into models with this add-on panel. And now you can basically go to all the general settings, image textures, and so on, which is the core of VoxelVision. The first thing is the voxelization method, which is currently at best performance. It's best performance because it is best when it comes to holes in the model. It basically handles everything and basically converts anything with a success rate of like 99%. And all those others have some flaws. This also has some flaws because it's not as precise. The problem with this model is, for example, as you can see, we have an open bottom. So it has a hole in it, which is not convenient if you use another method. For example, if you use volume-based, have a look what happens. It looks like this. It's horrible. And this happens because it wants to create a volume, but as it is not a closed mesh, doesn't know where it is outside, where it's inside. So this is not a good option for this, but it is precise. So in case you have like manifold object, you could use volume-based. Then I also have better hole resistant. So if I use this one, it is more precise. It still works with this hole, but if you have like bigger holes or intersecting geometry, this will also fail. So keep this in mind if you work with it. But if you look at this, for example, and I change this to best performance, you can see best performance is a bit thicker and it basically smooths the entire shape and is less precise. So in theory, use precision or better hole resistant or volume based if you can. If not, best performance is the way to go, basically. Let's keep it at best performance, or yeah, let's keep it that way. Then we have smoothing algorithms. So in this case, organic is the way to go, which basically just places stairs and slabs everywhere where it can, so it smooths out basically. But there's also the precise mode, which is not gonna work in this matter because we have a hole in the model, which then cannot calculate where's the outside, where's the inside. So in case you have a hole in it, you cannot use precise mode. Precise mode would, in most cases, when your model is manifold, work in the following way. So you would basically calculate if a full block can be inside of the original model. If yes, place a full block. If not, it will then check if a slab fits in or a stair, and which corner of the stair is inside, outside. So then it basically chooses the correct angled stair or flipped stair, and this way it's the most precise in terms of how it matches the original shape. Let's keep it at organic though. And then we have the color detection algorithm. So this is sharpening at the moment, and then you have blending, which blends and bleeds colors more into it, which can be useful in some cases, sometimes not. So I will also keep it at sharpening. Then we have some settings for the exterior thickness, so you can thicken your model. Then you have interior thickness, which basically increases the interior thickness. And then you have the most wanted options, basically. If you want to use stairs, use stairs. If you want to use slabs, use slabs. If you don't, you can basically disable it. Then the next question is, do you want to use or fill the interior? In this case, it does not even work because we use best performance. So keep this in mind, because best performance does not work with fill interior. All right. So Now we can open the next panel, which is details and resolution. So we have different options over here. Align block to grid is basically an option to align all those blocks to the grid. But as you can see, it is already aligned. So this only works if you are like unaligned. Then you have use image plane in case you use a plane that you want to convert with an image, so just like pixel art. Delete alpha if you have alpha channel and want to delete alpha channel blocks so you don't have like glass blocks around. Alpha threshold, so you can define how much alpha is deleted. And then we come to the resolution. So in case you don't like the current, well, rough color detection, you can increase the resolution. So at the moment it uses auto resolution, which is like 1. If you do higher counts, like 15, it will get more precise. So 15 to 1, you can see it, this is more rough and noisy. It's to 25 and you can see it's more defined. If this doesn't work because you use, for example, a grid pattern, like a texture that is already pixelated, I would recommend using subdivide mesh instead. So disable this and use subdivide mesh instead, because then you don't have random points basically, which are utilized with the auto resolution. Then we come to the mesh attributes, which are for one, the UV map. So the UV map is the map where the texture tries to align vertices or faces with the texture. So in this case, it's called UV map. In this case, it's called UV map. And then it works. If you don't see any texture, it's just not appearing, but you applied it, you can check or should check if this aligns your UV map that is active. And then you have color attributes. So this is pretty helpful. For example, if you don't want to use textures, if I click on use color attribute, you will see everything turns black, which is pretty annoying. What can we do? So color attributes are basically vertex colors. And with this, you can basically paint your model. So to show this, or as an example, I hide the blocks and I go into vertex paint mode. And you can do this with Ctrl Tab, or if you move to the top left and go to vertex paint. At first, you will not even see anything because you need to go into solid view. So set again solid view, or you can go to the right top and click on this little ball icon and go to solid shading. And then you can basically paint any color onto your mesh. So like this. So here we want to have like some blue, and maybe want to have some green over here, and maybe want to have some orange over here, and maybe some dark blue for the teeth. And then you can basically go back into object mode. The colors will disappear. And then you can go to color attributes and have a look how the attribute is called. So in this case, it's attribute. So I actually type in attribute, or you can click on sync and it will then sync the name with the active color attribute. So if we go back into shading and unhide our blocks, you should then see, oh, okay, all of those colors are now in here. And you can actually do this in preview, so you don't need to hide blocks, and you can do it in real time, but it would keep an eye on the performance. So you actually, don't be annoyed if it takes a while, because it calculates like 1 second per frame. So we can go into vertex paint, go into this and maybe get some brown color, and then you can click and paint onto the mesh directly. Just like this. Pretty awesome, right? So for this example though, we can disable color attributes and it will then jump back and use the textures, which are actually in the next panel option. So in this case, in total, you have 10 image slots that you can use. In case your model has more than 10 textures, you're pretty much screwed, because VoxelVision cannot use more than 10 textures at the moment. So in this case, I would highly recommend baking your textures. There are free add-ons for it, and you can also buy add-ons that do exactly this, to bake textures from multiple textures into one texture, or even solid colors into a texture. In this case, we have 4 textures. They are auto-detected. VoxelVision tries its best to auto-detect textures. If it doesn't detect textures automatically, you can then basically add it from this menu over here. And you should do this in the right amount how it is set up in the material. So this object, if you come to this properties panel again, you have this material button, and then you can see material 3, material 3, material 0, material 0, material 1, material 1, material 2, material 2. The order should basically match perfectly, otherwise it can screw up the texture or the color detection. The core of VoxelVision is that you need a texture or vertex color data. If you don't have a texture, you cannot use VoxelVision for this model unless you bake it. And yeah, I will link some baking add-ons down below. Some are free, some are paid. Choose whatever you want. So we actually jumped over the advanced settings at the moment. So in this case, it is block size. You can change how big the block is. I would actually not recommend touching it because, well, you don't really need it in case you want to export. Because if you change this to 0.5, for example, it will get smaller. And you can see now you have like holes in it. And VoxelVision will give you an error that you cannot export unless you change the spec to 1 meter. Then you have model scale, so you can actually scale the model afterwards, which is also not really recommended. And then you have join all parts. So advanced settings are just for Blender internally if you want to render something or make a cool effect, but it's not something you can use for exporting it to Minecraft. In case you don't like any of those blocks or how it detects basically maybe this is too sharp, you can actually introduce variation with this variation panel. So in this first section we have the noise variation, which is scale, strength, detail, distortion, roughness in a seed. So if I crank up the strength to maybe 0.5 or maybe 1, you can see it gets very, very noisy. And you can then change like the scales. If you change this to like 0.5, you can see we got a lot of big spots, which are actually looking pretty cool on this model. And you can change the seed. So the seed is basically where those spots appear. So you can change it. You can also choose if it should influence the color. And if so, yeah, then you can see we have some pretty funny rainbow styled skulls over here, but I would not recommend it. The second option is the block integrity feature. In this case, it's 100%. If you do 50%, it basically dissolves the blocks slowly. So in case you have like a fluffy tree or something else, you can basically just make it more fluffy. So 25, only 25% of the blocks are here, and so on and so on. Let's change it back to 100%. The next thing is the block palette, which is really interesting because, well, you can see you have all sorts of blocks that you might not even like. So for example, you can see crafting tables. So let's disable utility blocks. Crafting tables and utilities are gone. Maybe you say, I don't know about the grass block. I don't know about the path block over here. Let's disable natural blocks. Let's disable falling blocks. So all sand and gravels are gone. Maybe you don't like that creative blocks are used, like comments blocks. Let's remove them. Maybe you also don't like that transparent blocks are used, so let's remove them with transparent, and so on and so on. So this is basically just like preset selection. You don't have to use it, but you can use it. To further extend your palettes, you can go down to the custom block selection. So you have all those blocks in here, and yes, if you installed mods or model blocks, you can also see all the model blocks over here. And let me show how it works. So in this case, let's see if we can find something exotic over here. For example, you want to use all those ores except redstone ore. So you can click on this little arrow and then you have a search bar. So let's search for redstone ore, and you can see we have our redstone ore and deep slate redstone ore, and we can add it to our block palette. If we enable this block palette, you can see, oh shoot, everything is now out of redstone ore blocks. So this is like the first option that you have with the custom block selection. Just say, okay, which blocks do you want to use? Redstone or redstone blocks. Perfect. However, maybe you don't want to use exactly those blocks. This way you can go to mask out selected blocks. Click on it, and now you can see exactly those blocks are now gone or removed from your build. So you can actually go in and say, oh, glowstone. I don't know about glowstone. Glowstone should be gone. So that's pretty nice. If you want to, for example, save the palette for later, because either way you want to always use this palette, you make some cool palettes, you can save it and then load the palette over here. And if you want to use some presets, I also created some presets over here. For example, let's use the earth tones as a preset and then just use only those blocks. So now we have like a nice earth block option. Maybe a simple rock option is also cool. So now we get more of a statue kind of look. Exactly. And this is how the custom block selection basically works. And you can also disable it at any time. If you are happy with your block, you can actually go over here, click on schematic, and then you can click on export and it should be good to go. You can also do export blueprint and so on, what I just talked about. And then you can use it within of Minecraft. Just a reminder, you can go into edit, preferences, go for VoxelVision, open up VoxelVision, and then you can see we have those default file paths. And this is exactly what I meant in the first tutorial, that you can set up your block palette presets. So this preset database is basically where you always want to store your palettes. So you have like quick access to it if you load it. The same goes for blueprint and schematics, where you want to export them. So that's pretty cool. And this is pretty much everything that VoxelVision has to offer within this small N panel. And in the next tutorial, we're actually going to have a look at the asset library, which is a pretty cool thing, where you can actually have a lot more options, a lot more unique opportunities. And I'm excited. I hope you are too. And I will see you in the next tutorial.